Okay, we're at part 284C3E. Line 22f1fa19c3e Argand Binet's Lucas Fibonacci algorithms Temp coefficient 5G Wow Seti. Here's the alien radio signal from Wow Seti, and that's the numbers we Googled. And July 22nd is when I was doing the work on this. It's now August 27th, which is almost a month after. My thoughts. For the video line 22f1fa19c3e Manifolds, Algebraic curves, complex numbers 5G Wow Seti, I've done more research on the keywords from X equals on line 22f1fa19c3L. So basically I've split the data into two videos, okay? But of course, I did it in the middle of something, and then the other videos I started working on expanded, and unfortunately got from D to L, okay? Sorry about that. So I'm going to Google Argand diagram, and there's the equations for it. And that's an Argand diagram. So a complex number can be visually represented as a pair of numbers forming a vector on a diagram called an Argand diagram. The complex plane is sometimes called the Argand plane because it is used in Argand diagrams. These are named after Jean-Robert Argand, 1768-1822, although they were first described by Norwegian-Danish land surveyor and mathematician Caspar Wessel in 1745 to 1818. Argand diagrams are frequently used to plot the positions of the poles and zeros of a function in the complex plane. The concept of the complex plane allows a geometric interpretation of complex numbers. Under addition, they add like vectors. The multiplication of two complex numbers can be expressed most easily in polar coordinates. The magnitude or modulus of the product is the product of the two absolute values, or moduli, and the angle or argument of the product is the sum of the two angles or arguments. In particular, multiplication by a complex number of modulus 1 acts as a rotation. July 22nd, my thoughts. The key word is rotation. You need this for the outer shell of the UFO engine. So Binet's formula is a key word, and that's from www.maths.surrey.ac.uk. So I googled Binet's formula, and it comes up computing Fibonacci numbers using Binet's formula from 2011. Bosker blog. Quote, several people suggested that Binet's closed form formula for Fibonacci numbers might lead to an even faster algorithm. That's an interesting idea, which we're going to explore in this post. So what is Binet's formula? It goes like this. So he has the equation. Is the golden ratio. Computation time of Fibonacci numbers. So he's got the numbers, and there's the graph. Okay. Clearly, the integer method is faster, but the curves are not obviously different shapes. A log-log plot shows the relationship more clearly, and that's at bosker.wordpress.com. Okay. Next comes the Lucas numbers formula, and that's from mathsurrey.ac.uk. Quote from Wiki, the Lucas numbers or Lucas series are an integer sequence named after the mathematician François-Edouard Anatole Lucas from 1842 to 1891, who studied both the sequence and the closely related Fibonacci numbers. Lucas numbers and Fibonacci numbers form complementary instances of Lucas sequences. The sequences of Lucas numbers begins as 2, 1, 3, 4, 7, 11, 18, 29, 47, 76, 123. The sequence A0000032 in OEIS. All Fibonacci integer sequences appear in shifted form as a row of the Wythoff array. The Fibonacci sequence itself is the first row, and the Lucas sequence is the second row. Also, like all Fibonacci integer sequences, the ratio between two consecutive Lucas numbers converges to the golden ratio. So obviously this was a data learning video. Okay, so I'll go on to the next one.